Welcome to the first episode of the SimpleDAO Enterprise Hands-On Tutorial, Single Table Scenarios. This series assumes you already have a foundation in Java, SQL, and Spring Boot. Over the course of 8 episodes, totaling about 1 hour, we will take you from zero to production ready, covering the full spectrum of enterprise relational database development with SimpleDAO. In this first episode, we focus on single table CRUD operations, automatic audit field population, and logical deletion. Let's start by looking at the project structure. This is a standard Maven-based Spring Boot project. It has only 2 main dependencies: Spring Bar, Boot Bar, Starter Bar, JDBC, and SimpleDAO, which is the core of our framework. To make it easy for everyone to follow along, we are using an H2 database, but you can swap it out for MySQL or any other database. One thing to note, under the hood, SimpleDAO is essentially Spring JDBC. When you previously used MyBatis, the transaction management, connection pooling, and data source were all ultimately managed by Spring JDBC as well. What SimpleDAO has done is take this to the extreme: object-oriented single-table operations without writing SQL, direct SQL for cross-table queries, and ultra-simplified dynamic condition building. Now, let's look at the configuration file. It's the standard Spring Boot data source configuration. Below that, we've configured the application to automatically initialize the database schema on startup, which makes it easier for learning purposes. The SQL script contains our table creation statements. As you can see, these are typical fields, named using the underscore convention. Later, you'll see how the framework automatically maps them to camel case properties in the entity class. Next, let's look at the user entity class. This is a plain POJO using Lombok's data and builder annotations. Pay attention to 3 key points here. First, the table annotation tells the framework which database table this entity corresponds to. The table name is C's user. Second, the ID annotation marks the primary key field. By default, it uses the Snowflake algorithm to automatically generate the ID. Third, the 4 audit fields, create by, create time, update by, and update time, are handled automatically by the framework. The doctor field is a logical deletion flag. If this field exists, the framework performs a logical delete. If it doesn't, it performs a physical delete. That's all the code for the entity class, a clean POJO with just 2 annotations. Now, let's look at the complete user DAO. It's an empty class that extends base DAO with the generic type set to user, annotated with repositories so Spring manages it. That's it. With just this single line of inheritance, user DAO automatically gains access to over 50 methods covering all single-table and cross-table operations: save, update, delete, find by ID, list, page, and many more. For single-table scenarios, absolutely no coding is required. Next up is the condition class user cond. This is today's highlight, and chances are you haven't seen this approach before. It extends base condition and is used to build dynamic query conditions. Inside the add condition method, we define our query conditions. Look at this line, and name like, name 3. What this means is, if the name field has a value, it appends and t.name like, where t is the main table alias. The parameter value is automatically wrapped with % signs on both sides. The 3 indicates a both sides fuzzy match. Now look at age min and age max. These are fields defined in the condition class. If you pass values for them, the corresponding equals or equals conditions are appended. If not, the framework simply ignores them. This line is an inquiry. If you pass an IDs array, the framework automatically expands it into nt.idn, and the parameters are automatically collected. Any field in the condition class can serve as a query parameter coming from the front end. You simply define the fields, then chain them together using the end method inside add condition. No XML tags, no if statements. The framework handles null checks and parameter collection for you. Finally, let's see how to use it in the service layer. Inject user DAO directly, write the complete CRUD logic, and then we'll examine the logs together. Step 1. Single record insertion. Call user DAO.saveUser. Look at this insert statement. We never set the ID, yet the framework automatically generated a 19-digit Snowflake ID. We also never set create time or create by, and the framework filled those in automatically. The doctor field was defaulted to 0. Step 2. Batch insertion. Use the save batch method, passing in a list of user objects. You can see in the logs that the framework executed 2 insert statements in batch for us. Again, all audit fields were automatically populated. Step 3. Query by ID. Use the find by ID method, passing in the primary key. Look at this select statement. It automatically queries all fields. The returned entity object includes all audit fields. Step 4. Paginated conditional query. Use the page method, passing in a condition object. Here we're searching for users whose names contain the character Zhang and whose ages are between 20 and 30. Pay attention to the logs. The framework first automatically generated a select count 1 to count the total records, then generated a paginated query with limit 010. We wrote absolutely no pagination logic ourselves. Step 5. Update data. Change the age to 26 and call the update method. Look at this update statement. Update time was automatically set to the current time, and update by was automatically populated. When we query again, the age is now 26. Step 6. Logical deletion. Call the delete method. Notice something important. The log does not print a delete statement. Instead, it prints update set doctor equals 1. The framework detected that the entity has a doctor field and automatically performed a logical delete. Finally, query all undeleted records. Pass in a doctor equals 0 condition and call the list method. The returned list contains only Li Si and Wang Wu. The logically deleted Zhang San no longer appears in the results. Throughout the entire process, you only wrote business code. Every single SQL statement was printed out by the framework for you to see, fully transparent. That's SimpleDAO's single table CRUD in action. Alright, that covers everything for the first episode. We've walked through SimpleDAO's single table CRUD from start to finish. 2 annotations on the entity class, the DAO class extending base DAO, condition building using the end method in the condition class, and direct calls in a service layer. Throughout the entire process, there were no XML files, no interface implementations, and no black boxes. The SQL printed in the logs is exactly the SQL that gets executed. SimpleDAO can also coexist seamlessly with MyBatis. The source code and example project link are pinned in the comments section. Clone it and run it immediately. 0 configuration, ready out of the box. Next time, we'll dive into cross-table queries. We'll explore SimpleDAO's true battleground, covering everything from simple to complex scenarios. See you in the next episode!